Hello everyone and welcome to Looking for Pythagoras 3.3. Our learning target for this section is I'll be able to find distances on a coordinate grid, otherwise known as a graph. Remember, we're dealing with the Pythagorean theorem here. We have a squared plus b squared equals c squared. We want to also remember that a and b are both legs of our triangle. A and b are both legs, and it doesn't matter which one is which. What's important though is that we identify the hypotenuse, the longest side, which is opposite the right angle, okay, opposite the right angle, and that's side C. So we have a squared plus b squared equals c squared. And down here I've shown that a little bit, that let's pretend that our distance was this horizontal line, which we'll call C. Well, then we just make a right triangle out of that and find those distances. I have this one labeled as 3, this one is 4, and we could find out that the distance here of C is going to be 5, and I'll walk you through that in more detail here as we go along. 3.3 ACES is 7 through 10 and 18 through 21, 26, and 32. So it tells us that investigation 2, which we're dealing with on page 44 here, found the lengths of tilted segments by drawing squares and finding their areas. You can also find these lengths using the Pythagorean theorem. I want you to do parts A through E. Go ahead and read through these questions, ponder them, and they may help you with coming up with some of our answers here. So part A, it says, first I scratched out, copy the points above onto dot paper again. Use graph paper. We don't have to use dot paper. And we're going to draw a right triangle with the segment KL as its hypotenuse. So here's K. Here's L. This is the line I've drawn from K to L. Now we want to draw a right triangle. And how we do that is, grab this color. We'll go ahead and go from K over here, right below where L is. And we'll go L down to this. Now we have our right triangle right here. This is our right angle. So now we can come in and measure our A, which we'll call this A. This is going to be 2. And then we'll measure our B, which is 1, 2, 3, 4, 5. Okay, so 5. All right, so now if we use our Pythagorean theorem, which is poorly written by me, a squared plus b squared equals rc squared. Okay, we don't know what c is, we're trying to find it, but a is 2 squared, okay, 2 squared, plus b, which is 5 squared, okay, equals rc squared. Okay, so 2 squared is 4, plus 5 squared, or 5 plus 5 is 5 times 5, I'm sorry, is 25, equals rc squared. And then we have 4 plus 25 is 29, equals c squared. And we'll want to take the square root of each of these to find the side length. So the square root of 29, equals c. Okay, so our side length over here is the square root of 29. And that's how we do it. And then I'm going to want you to go on, and it asks you to do M and M and P and Q. So we'll do those same questions as we had back here in part A. Okay, do this just like I showed for part A. Do that for B and C. And then D talks about taking us back to problem 1.1, but we're doing the same thing. We want to find the flying distance between these 2 points. We had done the driving distance before, and it wants you to estimate the distance between, or the difference between those two distances. And part E, find the coordinates of 2 points that are a square root of 13 units apart. I want to see how you go about completing that in problem solving. Then again, 3.3, page 50, 7 through 10, 18 through 21, 26, and 32. Hope this is helpful. Let me know what questions you have, and look forward to seeing you in the classroom.